Okay, so this might be something you've done before: interpretation, interpolation, and extrapolation. So interpolation is, what does the equation of the line actually mean? What do the values mean? Interpolation is using the line equation to predict values that are in between existing values. And extrapolation is using the line equation to predict values that are either, they're outside the range, so they're either smaller than the smallest or they're larger than the largest. So we're interpolating your in between and extrapolating your either below or you're above the existing values. So copy that and come across. So interpretation of the line y equals mx plus b, and we know that m equals the gradient, and the gradient is the rate at which the data is increasing. So y equals 2x plus 5. The data is changing by a factor of 2, and then we're adding 5. With the y-intercept, this is just the value. So the y-intercept, if the data is that way, the y-intercept gives you the value when you have x equals 0, which could be, sometimes they use the word initial. So the word initial just means x equals 0 or time equals 0 or something, whatever you're measuring. So that's what interpreting the line means. So copy that and come across. So we've just got a couple of slides to go. So interpolation. So if the data, okay, so interpolation, you've got your lines, you've got your points, whatever, and you've got a straight line. Sorry, that's not very straight, but anyway. So we're trying to predict values that are in between values, and the closer the data is, the random data is to a straight line, then our predictions can be quite accurate. But if we've got dots that are all over the place and you make a straight line, there's not really a straight line there, so it's not highly linear, but we have made a straight line. But if it's not highly linear, then we're not as confident with our prediction. So interpolation is predicting values in between. So like our lowest value is there, our upper value there. If we're making values in between, we're interpolating. But if our line isn't straight, we have a straight line, but if our data is not really close to the straight line, then we don't have confidence. Okay, so copy that and come across. So extrapolation, so we've got our data set, so we've got our dots, whatever, and we've got a straight line. But if the lowest is there and the highest is there, extrapolation is when we've gone this way or we've gone this way, so we're outside the data set. And there's two problems that can arise. For instance, if it's not reasonable to expect you to predict values way away, so for instance, if our data is in months, like between January and March, you really can't predict what's going to happen in September because it's just too far away. Same with share prices. Things don't always keep going up. You can't predict. So some things aren't reasonable the further away you are from the data, from the original data. And again, if the data is only linear in a narrow range, we don't know what's like there might be a trend there, and then after that it just plateaus out. And if we don't know what's happening outside, it's very hard to say that the straight line is going to continue forever. So there's only sometimes data can be linear, and it's linear in a very small area. Okay, so copy that and come across. So in general, interpolated data, you can have more confidence than extrapolated. So when you're in between values, you can be more confident than outside the values. But again, the closer to a straight line you have, then the more confidence you have regardless. Okay, so first of all, if you're in between, you can have more confidence than if you're outside. And the closer to a straight line that you are, the more confident you can be with your predictions. And that's it. And there's an exercise to complete. Okay, bye.